We have 68 days until SEMA. We have an appointment at D-Sport. We need their help desperately.
Mike, you're good. Come on.
To try to sort out the issues we're having with this engine and to help us design the pistons that we're going to be installing in this engine. Getting this build right on this $100,000 engine is going to be crucial. We have to do everything perfectly. Things add up real quick when parts start to fail.
Mark, the van is officially V12 swapped.
Rear engine V12. Gotta stay hydrated. D-Sport is not just a regular machine shop. They actually had a magazine for quite a long time, so they're still a media company. Now they've transitioned more into very high-end engine machine shop for race car builds. Very detail-oriented, which is perfect for this build, right? We're going from a 750 horsepower, normally aspirated V12 to a 1500 horsepower twin-turbo V12. There are gonna be quite a few things that are gonna have to be modified and changed and adjusted to make it all work together properly. Evo with a parachute over here, we're in the right place.
We can't do anything today. It's a kosher holiday.
Yeah. Shomer Shabbos.
Yeah. You know too. Yeah.
Yep. I know. Did it make it?
Looks like it moved.
Didn't even move. I was driving nice though. All right, wheel this thing in. All right guys, so we're over at D-Sport now. Michael's gonna give us a quick tour. There are a lot of project cars they have.
Yeah, well, with D-Sport magazine being around for over 20 years now, a lot of projects both from before I started the magazine and to this date, there's been a lot going on. Here, this is actually my first car. I still have it. Oh, that's so cool.
That's sick.
So this is a 69 Super Sport 350, undefeated in street racing back in the days.
Yeah.
I used to go to street races and never lost a race with it. You'll know I'm successful if I get back on this. That's when success in life is at. Once the Camaro kind of faded out and I had that Talon over there for a little bit. The Eagle Talon was kind of my first taste of import performance, real high performance.
Yeah.
What I found out then is that I love the combination of all-wheel drive and turbocharging. That car was so much fun. I mean, I used to go to Carlsbad back in the days every weekend and do a little bit more and got the car to run 13s, then 12s, then 11s. And just as it started getting into the 11s, every pass was breaking a transmission. And it just became not fun anymore. And I heard about the Skyline GTR in Japan and how amazing it was and all this. And there was a company called Motorex that was starting up and they were going to be bringing the cars over. And so I went over there for one of our Tokyo Auto Salon tours that we do. I went to Up Garage and I bought the steering wheel adapter.
Yeah.
So before I bought the car, I bought the steering wheel adapter.
Yeah, exactly.
So I could stick my, my Sparko or whatever on there. I came home, I go, well, I guess now I got to
buy the car.
Yeah. So
makes sense.
I called the guys over at Motorex, ended up with this car and then trying to see how much power we can make on the stock engine, stock turbos, kind of everything along the ways just to learn as much as we could. And it's funny, we've had the same turbochargers on this car. These were the biggest, baddest turbos you could get in like 2003, which was the Apex Turbo Kit.
Oh yeah, I remember that.
We kept it on the car all this time and just keep trying to push the performance. And what that forced us to do was to do all of the other engine development around it. Yeah. How do you make the heads work the best? How do you, what cams, what timing, all this stuff.
You're optimizing this whole package. Like, these are the parts we're working with. How can we optimize these turbos to work and the flow and and this thing makes like 1300 horsepower, is it?
Yeah, it makes about, I think, 1260 off the bottle and about 1380 or something on the bottle.
Yep.
I wanted to keep the car streetable. I mean, I have a Hollinger in there. The clutch is awesome. I wanted a clutch that would feel like a street car, so it's a quad carbon Tilton.
Oh yeah.
And it's amazing. I mean, anybody could drive this car.
Yeah.
That's kind of a cool project that we did. The first project that we did for a major OEM at SEMA is the 2014 Fiesta ST that we did here, which has that EcoBoost 1.6 liter.
Yeah.
And the concept there was, at the time, Pirelli was the sponsor of World Challenge Racing.
Yeah.
And there wasn't a class that had like 300 plus horsepower front wheel drives in it, hot hatches and stuff like that. So I said, well, if there was, this would be a good candidate, and this is how we build it. So road racing cage, a full race turbo kit on it, did flex fuel on it. So it makes about, I think, 340 horsepower and pulled about 200 or 300 pounds out of it. It's a fun little car, and Ford loved it. That was cool. They're like, most of the time we give people our cars and they just throw a bunch of garbage on it and put it in our booth. It's like, you actually made cool stuff.
Above and beyond most SEMA builds.
Most SEMA builds don't even run.
Exactly.
I think 90% of them, if you stuck the key in there and turned it, nothing would happen. The most recent one we did was with Lexus. Lexus, that IS 350.
Yeah.
Still finishing up the transmission. Actually, a lot like you did on that car. What was it? The Porsche, was it? That had the air shifted sequential and all that?
Yep.
My inspiration was that.
There you go. Yeah, I know. When you saw it on the dyno, you're like, I need more info on that.
Yeah. I really think that's the best of it. You know, I mean, the car's a lot more enjoyable if it has that third pedal.
Yep.
But if you really want to get the ultimate out of performance out of it too, it's hard to beat a dual clutch. But if you have a sequential air shifted with a clutch pedal, man, that's everything.
Yeah, exactly.
I mean, it
makes all the goodies.
Yeah, it's everything. It's just as good as it can get right there.
Yeah.
So yeah, cool little car.
Yeah, it is. It is very cool.
So the GTR was going to be coming out, the R35, and I remember being interviewed by Nissan and some of the magazines in Japan and stuff. And I said, look, if it's not going to have a manual transmission, if it's gonna be dual clutch, it's not gonna be a Skyline GTR. Don't even call it a Skyline GTR.
Yeah.
Well, whatever, they listened to me. So this is, the Nissan GTR. It's not the Skyline GTR.
Yeah.
I hated the car when it first came out. When the R35 first came out, it was so bad. You'd get behind the wheel and it was like one of those really bad versions of Windows where you try to do something and it's like, are you sure you want to do that? Like you push down on the throttle, it's like, are you sure you want full throttle? I mean, there was that much lag and everything happening.
Well, I remember I drove these in a few configurations fairly early on. Somebody wanted me to try to drift one, but they're like, don't turn everything off, because if you turn everything off, then it basically voids warranty, but slide it. And it was just like, as soon as you get any slip angle, it's like shuts everything down.
Yeah. What I like that Nissan did is by 2012, when they did the minor change, the car completely fixed 99% of those problems. So after they did that, I'm like, okay, I'll get one. And basically just full bolt-ons and stuff. We did a Motec standalone.
Bolt-ons with a Motec.
Bolt-ons with a Motec. I mean, you need the data logging, right?
Yeah.
If you don't know, you're guessing. So so it's just basically, stock. But we got this to run, low 10s as it sits.
So we're going to head back into your machine shop area.
Alrighty.
I've been back here a few times and it is very impressive.
Yeah, it's known as Club D Sport. It got the name because Magnus, who is our original machinist and the guy who taught us everything we know here, he used to like to put all these Euro trance dance beat stuff going on.
Oh, nice.
So this is it. Now, what is this?
The engine out of a 2013 F12. So it's a 6.3 liter. Yeah, I'd like to hear your thoughts on it. You've done a lot of different types of engines.
Yeah. This is kind of interesting. So are these the actual...
So there are no main caps.
These are kind of the main caps, then, huh?
Yeah.
So what I'm seeing here, I'm noticing that both halves of this engine are completely aluminum.
Yep.
Completely cast aluminum, so there's no steel inserts in here. So I'm guessing if we were to get the actual specs for bearing clearance and stuff like that, it's probably on the real tight side. I mean, it might be like 1/1000th of an inch or something like that.
Yeah.
And because of that, because there's so much growth here and stuff, a lot of these engines that are set up this way have to run dry sump boiling system. They just have to have that volume of oil filling it, because that's going to change dimensionally as this thing gets hotter and hotter.
Yeah, so basically when you first start the car, the clearance is very small.
Yeah.
And as it warms up, it's the right clearance. When
Exactly. Getting the right oil for that too is important. You want to look for an oil that's going to have a high viscosity index, and that'll help you get a more consistent oil pressure.
Between cold and hot.
Yeah. Oh, that's not bad at all. All right.
Inner washer.
Yeah.
Might have fell on the floor.
Got it.
All right. So
That one's black.
No, that's not the right one. That's a different one.
Oh no. Well, pick that one up. That one should be there. The first thing I see is that there's definitely evidence of some contamination in the oil.
You are correct. So the main reason we tore this thing down was because we pulled the oil filter on it and we found bits of metal. And then we pulled the intake manifold off and there was metal on the inside of the intake manifold.
Was there no air cleaners on the turbos?
There was no. It was screens. So it's lived a hard life.
It definitely has. I mean, these bearings, it's interesting. The front one looks like it, pretty much should.
Yeah.
You should see a bearing look like that. If you have a bearing that just, has that same color throughout the whole thing, everything's working right. If you have a bearing that's showing shininess just in the center there, depending where it is, it could be a detonation issue, another issue, and stuff like that. But here, when you see something that's coming in and then just getting wiped across the bearing, that's contamination of some sort. And probably if you feel this stuff down here, Might be a little gritty too.
Yep.
And if this thing spins a bearing, it's not going to be fun to fix it
It's
at all.
toast. Yeah. If we threw a rod in this motor, it would be a $40,000 plus mistake.
I would expect we're going to find this stuff to be in pretty good shape. Now, if it isn't, we can fix that. Essentially what we would do is we would machine this perfectly flat, jig it up, machine it perfectly flat, machine the block perfectly flat, and then we would go in and line bore
it. Yeah, so you're basically taking the two circles and making them smaller. Exactly. And then cutting this area and this area out of it.
Exactly. Yeah. But it is a challenge because if you look, it's about 29 inches to the edge of the case to the edge of the case.
Yeah.
It's probably an operation that would be tied up on the CNC machine probably 3 days straight, just to get it, because we have to get everything perfectly aligned, and then we come in and we're boring it, vertically, and we have to keep changing the length of the tooling and resetting and remeasuring and doing the whole thing. Let's cross our fingers that after we clean it up and measure it, we don't have to do that. All right, let's see what they got.
Yeah, you can check out the bearing on that one too.
It's a full floating piston like an aftermarket piston would be.
Yeah, it's cool. So the top of the rod is actually tapered in.
Yep. That's become more and more common because you don't really need that there, but this rod is great for NA and
exactly.
But when you start boosting it, this is going to be the weak link in this engine. There's just not enough cross-sectional area. There's just not enough mass to take all that compressive force.
Yeah.
And you'll end up bending a rod. When that happens, all hell breaks loose. I mean, there could be windows in this block and lots of stuff happening. Yeah, I'm sure it's probably a $100,000 engine or close to that.
Yep.
That you start messing it up, trying to tune it in that window, and you mess something up, you're gonna it's gonna be a big bill. I think it's the right choice to kind of just go with the port fuel injection.
Yeah, simplify it a bit. Yeah, exactly.
Well, the first thing we can do now that we're at this point here is we can check this crankshaft for straightness. Mm-hmm. That is number one, probably the home builders and the guys out there that are just buying the parts and putting stuff together. That's the one thing that they miss, and when they have bearing issues, 9 times out of 10, it's because the crank shaft has been bent.
Right?
Yeah, it's bent some way. Yep. Wow, this thing, for as big as it is,
it's not crazy heavy.
Yeah.
I'm a little stressed out right now because if the crank is warped, that's a huge expense. It's probably close to $20,000, maybe more, if we have to get another crank from Ferrari. I don't know how long that would take. I mean, basically, if there's a problem with this crank and it can't be fixed, I think our hopes of getting this car to SEMA are just down the drain.
Kind of where we're at. We've got about 1,000. Yeah, 8 to 9 tenths more than I'd like to see.
Put this in a press and
No. Worst way to do it. If they put it in a press and they press it, you'll get it straight. You put it in the car, you run it, it'll go back to the way it was.
Oh, wow.
The way that they do it, they get a big hammer and they use a chisel that looks like this, and they know exactly where to hit it to relax it.
Yeah, so it almost reshapes the metal into shrinking it a little bit.
Yeah, where that, because it's not straight because there's some tension in some place, and it's almost like a combination of acupressure and acupuncture. Yeah. But they're tapping it in the right spot, and it gets it straight again. Okay, so there's not as much bend between this and that axis, but this one's a little kicked out. Yeah. What we see here on the crankshaft too, this is also what happened from having those debris going in there.
Yeah.
I mean, they definitely went on the lightweight side.
Yep.
And the thing about crankshafts is they always say mass will save your ass. So when you start taking the mass out, you're rolling the dice a little bit.
Good news on the crank is that it can be fixed, but every time there's another process and something else has to happen, that adds more time. Like you guys know, we have 68 days from today to finish this car, get it running, and get it to SEMA. And everything that we're finding is just adding time to it. It is not shortening that time frame at all.
Here's the deal. You were talking about time. The challenge that we have is, I think you were able to measure that the thickness of these sleeves is only about 2 millimeters.
Yeah.
That's generally not enough. I mean, generally for a boosted engine, you want to keep it closer to 3 to 4 millimeters, somewhere in that range.
Yep.
I'm sure it's a great material, but if we can make it thicker, we are going to be able to get a lot more horsepower safely.
This is a normally aspirated engine, and we're turbocharging it. So there's so many components that are built very specifically for a normally aspirated engine, and built as light as possible, as thin as possible to make as much horsepower in that configuration.
Exactly.
And we're going the complete opposite direction.
Exactly. The key will be is, can we design, find, locate, whatever, get a sleeve, minimize the amount of machine work that needs to be done in order to install it. Like, if we can make one that dimensionally on the outside matches what Ferrari did, then we have a pretty simple thing. If that's not an option, then we're gonna have to design a custom sleeve and this and that, and it's gonna be one of those things where you're talking about your timeline. It's gonna be a lot tougher to hit those, to be at SEMA. So
I hope that doesn't happen.
I hope it doesn't happen too.
I know that this is such an unusual engine to work on. I don't think that many people have built race engines out of these, and if they have, it's kind of a mild version.
Right.
And it's not a twin turbo setup. We are doing something that I honestly think no one's ever done before. So I understand the time frame and the delays in getting custom parts made. I don't want to hear it because I want to meet my deadline, but I do understand it.
I think I've got a Porsche block in here. You can kind of.
So a Porsche block, another all aluminum block. If it's an older air cooled one, if it's a M96,
you know what? You found the wrong guy to tell you what.
So it's an M96.
Okay, there we go. I know it's got 6 holes in it. Okay.
No, it's not an M96. It's a newer one.
It is a newer one. It's a water cooled one, and with the Ferrari engine, it'll be looking like this when it's in here. Rotate the engine 360 degrees. So we'll make sure that we get it so that when everything is decked, everything is perfectly 65 degrees between the two.
Got it.
Everything will be in perfect alignment. You're not going to have a rod pulling one way or the other and doing weird stuff like that.
Yeah, or a piston sliding through the board at a slightly cocked angle because it's board crooked. Yeah.
What we do for the blocks, we actually do for the heads also. And that would be making another fixture that allows the head to be bolted onto that, so when we go in with the CNC and cut the valve job on it, it's already distorted. How much information can you get from Ferrari on these engines? Nothing?
It's so difficult.
Because with Porsche, we don't get anything. We have to reverse engineer all these things. We get new parts, we put them together, we measure them out, and we say, okay, this must have been the range that they're looking for, and we'll just to be safe, if it looks like they go this far, we'll go this far. We just keep the tighter tolerances on everything.
Yep.
All right, so that one has good seal. Let's try this one. And this one does not.
Yeah. Not nearly as good as the other side.
Yeah. Nice.
Now, did you notice on your engines, whenever you had a valve train problem, was it typically on number 1 or 6?
It was almost always on number 2.
Really?
Yeah.
This Ferrari engine has a very nice chamber shape. This area here where the direct injection, of course, since we're not going to be using that, that'll be welded up and plugged, but we can get this contour to follow this. And you notice it's almost like a clover leaf design. So they have a really small, tight combustion chamber.
Yep.
And that's perfect. That's what you want. The more of this area you can have here on the sides here, this quench area, the better off you are, because once that piston comes up to top dead center, we're going to set this clearance super tight. I mean, it'll probably be like 32,000.
Between the piston and the head, it'll basically want to force everything to the middle.
Exactly. Yeah. It'll push it in here super high velocity, great mixing, everything will happen. Your flame doesn't have to travel too far to completely ignite the chamber.
Yeah.
You've got this much this way. There's more in this dimension than that dimension, but relatively quick burn to get most of this going, and then as the piston's coming down, it's just going to light up the rest of it.
Pulling some of the valves out, the valve springs, just so we can get a better idea of is it a beehive shape, is it a dual valve spring, are they stepped heights? It's going to point us in the direction that we need to go. Do we need to get different valve springs to get more seat pressure on them? Can we shim them to get more pressure on them? And that's basically because we're going to run a lot more boost than we were running. Obviously, this is a normally aspirated motor, and they don't have any issues with the valve springs except for float at RPM. So they make it as stiff as it needs to be to not float up to their red line, but no stiffer than that, because you don't need that extra resistance if it's not required. In this setup, it is going to be required.
It is, yeah. So we have the option, like you said, either going to a spring that'll fit in here that has a little bit more seat pressure, maybe has a little bit higher rate, or can we get away with just shimming this up and giving it more seat pressure, and will that do the trick? So that's what we'll have to find out. We'll have to see exactly how much lift the factory cam is giving, how much clearance we have between all these items here.
The amount of lobe on the cam is how much this gets pushed down. So if it's 12 millimeters of lift, if you push the spring down 12 millimeters, you have to make sure that these don't touch each other, because then you get coil bind, and when you get coil bind, it goes from a certain spring rate that's increasing to infinity. It's basically solid at that point. You'll break the spring or you'll damage something else in the valve train. So it's very important to make sure that you get all of these things correct.
Now, if we put a shim under there, Here's a couple shims.
So basically the machine right now is moving the same amount. So he's not changing the amount the machine moves. It's basically like, okay, 33 millimeters of spring, because springs have a rate to them. Sometimes they have a tapered rate, sometimes it's softer and then it gets stiffer, sometimes it just depends on the spring. So we picked up 20 pounds.
Pick up 20 pounds of seat pressure there just by adding those 2 shims in. But that might not be doable because we may run out of clearance. The retainer itself here, this might be coming down and hitting on the valve seal or the valve guide. It might be interfering with that, or the coils themselves might bind against each other. So things we got to look at, we got to, the whole trick is to measure, measure everything so that you're not guessing.
Yep.
And that's the key. So we got a lot to measure to figure all this out.
Yeah, they're just like, that's why we came here, because they have the knowledge and the tools and the expertise. They've done this before. This is a V12 that no one's ever done this to before. So it's going to take a lot more engineering to come up with the best formula for this engine to work, to do what we want it to do.
So this is the intake side. We already take a look at the exhaust side. Well, some interesting stuff we could see here. Mike had alluded to the fact that there was a lot of stuff going through the intake. Well, we're seeing a lot of that on the back of the valve here.
Yeah.
This is when a hot valve meets dirt and gunk and contamination coming through your whole intercooler and turbos, through that whole system, and just being put on the back of a hot valve, it'll tend to cake on there.
Yeah, it's basically melting and embedding that material onto the surface of the valve. This ring, if you can see that there's a shiny spot. That's basically the seal between the valve seat and then the valve, and they meet together, and that surface is what seals it up. So if there's debris that got in between there, it's going to be lifting the valve out, twisting the valve slightly. If it's in one spot, you could bend a valve, and then you're basically having a combustion go past the valve, which is like a torch that can burn the valves and it can burn the seats and just destroy the engine. So
Definitely. If we measure it out, we get lucky. We're looking at parts wise, you're looking at maybe $96 in parts if we get lucky.
We're being very, very thorough and looking at every item in this engine. And this is a multi-layer steel head gasket. So it's basically 3 layers of probably stainless steel with different coatings on it. And the middle layer looks like it's flat, but the upper and lower layers have basically raised sections that will get smashed down as the head is torqued down to the block. And that's how it creates the seal, along with, this like Teflon style gasket that they spray onto it. But it's just flat. So it's these 3 layers that are flat, and there's a possibility of the boost and combustion basically seeping through here and going into a water jacket, into an oil passage, or directly into the cylinder next to it. So if it does that, that's not good. So we want to check all of these things and kind of eliminate.
So what we could do, instead of just guessing, we could use Fuji paper. Now, Fuji paper, this is a pressure sensitive paper. How much pressure is put on it when you squeeze it and sandwich it between the head gasket and the block and the head, it'll actually show you what's going on. When we look at this one here, you see these light areas here.
Yeah.
This is a stock OEM head gasket for a Nissan RB26.
So low pressure here and higher pressure around here.
This is where it likes to leak. You look at some of the aftermarket gaskets for that. This is the Cosworth gasket that they used to offer for it.
Oh,
a lot stronger reds.
Yeah, much better seal.
And then doing a O-ring.
Okay, so this is actually groove in the block.
In the block.
And a metal ring is pressed into it. So it's basically above the deck.
It might be something we may want to consider putting an O-ring in there.
Thank you so much for helping us out with this. I know you got a lot of measuring and inspecting left to do before you can decide on which direction to go.
A lot of discovery.
And that was a very good trip over to D Sport. I learned a lot, and I hope that a lot of that info will also come across to you guys, and you guys can soak that up, because there's just so much that goes into building a race engine, and obviously Mike knows a lot. We are back, and we have a huge issue with the chassis. So in our efforts to get Damon in the correct seating position, it has been quite a challenge. Damon's tall, and we need to make sure that there's enough clearance for his head, but also that his feet and legs are in the right angle for the pedals. So because of the length of this car in the interior, it's actually pretty short. The hood is long because it's a V12, so there's a lot of room in front, but inside the driver's compartment, it's fairly short. and the roof line is quite low. We put the seat in here just kind of floating. We had Damon sit in the car, we measured it up. The back of the seat was touching the rear firewall, and the bottom of the seat was on the sheet metal floor. That was basically the best position that we could get him in. It just wasn't feasible to make brackets and actually get the seat into that position. So we've got the seat as low as we can get it and as far back as we can get it. We've also had to push the main hoop back. So our original main hoop position was right around here, and that is right above where he sits. That's not the biggest issue, but the side of that bar. So with roll bar padding and a helmet, he's gonna be, his head's gonna be 45 degrees sideways to try to drive the car. That's not gonna work. We actually cut out a huge piece of the frame, and it is this whole box section that goes to basically give the roof reinforcement. So if the car rolled over, the roof wouldn't collapse. But we had to cut that whole thing out to try to get the main hoop back as far as possible. Now we've taken a lot of strength out of the car, but we will put it back. This tube is a lot stronger than the sheet metal that we cut out of the car. So this is it's just pretty thin aluminum. It's very flexible. It's not that strong. So after I cut it out and looked at it, I was a lot less concerned about it. Just imagine if this car was a convertible from the factory and we built a roll cage around it. It'll be strong. So I don't have any issues or concerns there. I know how I'm gonna reinforce everything. But the problem we're running into right now is that this bar is almost as far back as it can go. This part of the sheet metal here is actually the exterior of the car. So if we cut this out, we will have a hole between the roof and the trunk. We can't do that. So I think we're gonna have to compromise here, and we might have to move the seat forward a little bit more, which isn't ideal. It's going to, put Damon in a less than ideal driving position, but that's a better compromise than either having the seat back here and him hitting his head. I'll show you a bit of what we had to do to get the seat into that position, because it was quite a lot of work. Custom fabricated a seat bracket and uprights and everything. So we're not going to use the original Sparco side mounts for the seat. And that's because we have to integrate those brackets into a strengthening plate, because we had to cut out quite a bit of the frame rail on the bottom and also notch a hole in the actual floor itself where there's a little step up to get the seat down as low as possible. So these are the brackets we made. Drew up a design in CAD program and then cut them out on the Jekran plasma table. They work really well. We were able to drop the seat down. As you can see, there's like a very, very small gap here. I just wanted enough room so if there is any flex, the seat doesn't actually rub through. Maybe a 3 to 4 millimeter gap there. And I actually built in adjustment into the seat on the side of it, because there's no room for sliders that you would normally go on the bottom. You lift a little lever and you'd slide the seat back and forth. That takes up about 3/4 of an inch, maybe a little more, and also requires these mounts to have a return edge, which is also more thickness, brackets, all that stuff. It would raise the seat up at least an inch, all said and done. So I created these slots. So basically you just crack the bolts loose, lift it, slide it, and pop it into another position. And the idea behind that is basically Damon's seating position and my seating position. So tall guy, short guy. So now that that's built in, crack those loose, lift the seat, slide it forward, drop it in place. It would be very easy for us to swap seat or swap positions in between. So if I go out and shake the car down and then Damon wants to hop in and get some laps in, we can make that quick adjustment. It's very easy to do. It's not, bolts don't have to come all the way out, and it's not two separate holes. So that was a good idea, but I think we might have to remake these. We might have to modify them more because the seat is still too far back, and I don't think we're gonna be able to move the roll bar, the main hoop, back anymore. We still have some more trimming and cutting that we're gonna do and see if we can get it farther back. But that's gonna take another few hours of just cutting and grinding. So that's what we're working on currently. This is a very time-consuming process to get the seats right in this car, but it's very important, right? Everything is going to be built around the driver, as far as the steering position, the pedal position, the shifter, the e-brake, how far out the door bars are to make sure there's enough elbow clearance. So all of these things happen after the seat is placed in the ideal spot in the car. And like I said, it's not looking like it's going to be as ideal as I would like it. We're gonna have to make some compromises, as you usually do with most race car builds, there's always something that has to get compromised to make something else fit, make something else work. The safety in the vehicle, that's very important for us. I want to make sure Damon's safe. I want to make sure I'm safe when I'm driving the car. It needs to be built properly. I've got a lot of work ahead of myself. We're going to try to kick this roll bar main hoop back a bit more. We're going to do some more trimming. We might have to remake the seat brackets completely to move the seat forward slightly. There's a lot more that we have to do. And that is just to get the seat into its position, to finalize the main hoop, which just opens up a lot of other stuff that we're going to have to figure out. All the rest of the cage design, all of the stuff we have to put in the rear of the car, the fuel cell, the radiator, all of this stuff needs to be packaged properly. We got 68 days left, and I have a lot of work to do.